Algebra 2, Lesson 60, what we're talking about today is distinguishing between mutually exclusive and independent events. And so there's going to be some terminology that needs to be read. There's going to be some boxes with information in them that isn't going to make a whole lot of sense just as you read it. It's going to make more sense as we look at examples and answer examples from these questions as we talk about things that are mutually exclusive, okay, that really don't have any connection with each other, and independent events. All right, I want to do some reading. All right, now I've got a lot of that reading already up there. Jose, can you tell me what a compound event is? Simple events. Simple events a lot of times are, let's say that we are rolling a dice and spinning a spinner, right? You guys know what I'm talking about with spinning a spinner? Have you ever played Twister, right? And it gives you different options, right? That's a simple event. Rolling a dice is a simple event. Pulling a marble out of a bag is a simple event, all right? Does that make sense? And so I have probability on each of those simple events. And they may mix events. They may say, what is the probability of rolling a 1 and spinning and getting blue left hand, right? And I could find out what that is. But that's a compound event that is made up of 2 or more simple events. Mimi, what is an inclusive event? Okay, events that have at least one outcome in common. This could be where I'm rolling 2 dice, right? Would they have events in common? Could I flip 2 coins and get events in common, right? So it's a little bit different than a compound event. It should have outcomes that are similar, okay? And then I have disjoint events, events that have no outcomes in common. See, a compound event could include inclusive events or disjoint events. Okay, disjoint events is like what I talked about earlier, where if I was rolling a dice and spinning a spinner, right? They should have no outcomes in common. Let's talk about two events that have no outcomes in common. Can you give me an example of 2 things that I could do that should have nothing in common? How about flipping a coin and rolling a dice, right? Can you roll a heads? No. Can you flip a 6? No. You see that they're not going to have any events in common because of they're 2 totally different types of things, right? All right, let's look at something else here. Let's talk about inclusive events. This is how we find them. Okay, remember, inclusive events are events that share a common outcome. Okay, we would take the probability of A and add it to the probability of B, and then subtract, okay, the probability of A and B. Okay, so you can write that down. It's in your book. You'll see it there at the bottom of page 427. And mutually exclusive events, for 2 mutually exclusive events, A and B, it's the probability of A or B should be equal to the probability of A plus the probability of B. All right. And then on the back page, on page 428, we talk about the probability of independent events. Okay, for the probability of 2 independent events, A and B, we got probability of A and B is equal to the probability of A times the probability of B. In general, if we have a list of independent events, right, we would take the probability of, it basically comes down to this bottom row down here, the probability of event A, or event 1, times the probability of event 2, times the probability of event 3, so on and so forth, until I've multiplied it by the probability of all the events. Okay? All right. So from this point, with these things in mind, all right, we should be able to start answering some questions. Okay? All right. If I can find my stuff here. All right. William is on the school archery team. The target has a center bullseye and 2 rings around the bullseye. The table gives the probabilities of each outcome. What is the probability that William will get the next arrow in the inner or outer ring? Okay? Express your answer as a decimal. Okay, so what we're seeing there is this either or. Okay, for 2 events, A and B. This is mutually exclusive events. All right, so we want to go to our mutually exclusive events. Right? Notice it was the probability of A plus the probability of B. Right? Okay, so what we're doing here is we are simply adding the probabilities. Okay? All right, and my probability here is either the inner or the outer ring. Okay? So the 2 things that I want to add together are here and here. So all we have to do is take 0.289 and add it to 0.423. Okay? They're mutually exclusive. Because you can't hit the inner and the outer ring at the same time, right? Okay, so what do I get whenever I add those 2 things together? 0.289 plus 0.423. 0.712. Okay? So you have to identify what kind of event we're talking about. So this is mutually exclusive because I can't hit both the inner and the outer ring at the same time. Okay? All right, do we understand that so far? It's pretty simple math, but the understanding there, we could do a lot of different things wrong with it. All right, check question number 2. Probability. Now let's go back and talk about probability for a second. What is probability? If I'm talking about it's something over something else, let's see what our understanding is. What type of number is on top? Number of desired. Number desired. Okay, what number is on the bottom? Number what? Total. Okay? Total. Just so we understand what we're talking about when we're talking about probability. Okay? So I'm going to erase that because we want... Okay? Find the probability of rolling a 5 or an odd number cube. Express your answer as a fraction in simplest form. Well, this is not mutually exclusive, is it? Right? Because 5 is an odd. Correct? Okay. So, because 5 is included, right? It's an inclusive event. We're really looking for finding the probability of rolling an odd number, right? Okay. So, how many odd numbers are there on a cube? 3. What are they? 1, 3, and 5. So what is my number desired? What is the total? Can I simplify that? 1/2, right? So 1/2 is my probability of rolling a 5 or an odd because 5 is included in that. Okay? All right. Slide this over. Number 3, determine if these events are independent or dependent. Okay? You draw a 7 from a deck of cards without replacing it. Then you draw a 2 from the deck. Okay? The question is, does the results from the second draw, is it independent from the first draw or is it dependent to the first draw? There's a really important phrase in there. 2 words, really, really important. Those words are what? Can we tell me? without replacing it. Okay? If I had put the 7 back, then the probability of drawing that 2 would not have changed, right? Because here's what happens, right? Because probability is number desired over number total. A standard deck of cards has how many cards in it? 52. I had a 1 in 52 chance of drawing that particular 7. Let's say it was a 7 of diamonds, right? Okay? But if I don't replace it and I want to draw a 2 from the deck, has it changed the probability? Now it's that. Let's say I want to be more specific. I want to say I want the 2 of diamonds. It's now 1 out of what? 51. All right? So are these independent events, or does the second draw depend upon what happened the first time? It's dependent. Okay? It's a dependent event because I didn't replace it. Now, if I put the 7 back, we talk about totally independent events because the probability remains. Okay? But if I change the total, now I've created dependent events. Okay? Does this make sense? Hopefully a little bit. We can wobble our head up and down, say, yeah, I understand what you're saying. Okay. All right, let's move this over a little bit. Oh, too far. Okay. All right, let's look at this question here. A grab bag contains 8 football cards, 2 basketball cards. An experiment consists of taking 1 card out of the bag, replacing it, then selecting another card. Determine whether the events are independent or dependent. What is the probability of selecting a football card and then selecting a basketball card? Express your answer as a decimal. So let's start off. Are these dependent or independent events? Independent. Because I did what? I replaced the card. Okay. Now that we know that they're independent, we have to find out, okay, what our probability is going to be. Okay, we've got 2 independent events. Let's go back to our notes. For 2 mutually, no, we're not mutually exclusive. Let's see. Here, probability of independent events. What am I going to do with the probabilities? Multiply them. Okay, multiply them. Very good. Okay, so let's come into this. What is the probability of selecting a football card? How many football cards are there? 8. How many cards total are there? 10. So I have an 8 in 10 chance of selecting a football card. Okay, and then selecting a basketball card. Okay, so what's the probability of selecting a basketball card? 2 in how many cards? Okay, 2 in 10. All right. Let's see. Actually, it's not quite right. And I don't know if they addressed that in this question, or if they're trying to address it in this question. I don't want to see. Let's see if there is an answer that actually... let's see. I want to... Now I'm going to disagree with this for a second. Now, oh, okay, I see what they're saying. Okay, because we're going to replace it, right? We're going to select a football card. We want to select a football card, then we're going to put it back, and then we want to select a baseball card, right? Or basketball, I'm sorry. If we didn't replace it, this number would change. This denominator to 2 would be 9, right? Which is, if you do that, you're going to get this. But 8 times 2 is what? 16. 10 times 10 is 100. Okay, what's 16 hundredths? 0.16. Independent, 0.16. All right, that's my probability, is A right there. All right, last question. Okay, and then you guys can get started on homework and all that other good stuff. Okay? All right, a jar contains 5 blue tiles numbered 1 through 5. And green tiles 6 through 10. A tile is drawn from the jar at random. Are the events that the tile is green and the tile is odd inclusive or mutually exclusive? What do you think? Inclusive or mutually exclusive? Inclusive. Can you explain to me why? You're right. It is inclusive. Can you tell me why? There's at least one. We're looking for a word here, common outcome, right? Now, if, let's say we change this. Let's say we changed our information here. We said that the contains 5 blue tiles, 1, 3, 5, 7, and 9. Okay? 1 through 9 odd. Okay? And 6 green tiles, 2 through 10 even. Right? And we want to draw a tile. What are the events that the tile is green and odd? Well, that would be mutually exclusive, right? Because all of my green tiles are what? Even. Right? Which means I can't get a green and an even. Do you see the point? Because there are green odds, we have an inclusive possibility here. So drawing a 7 or a 9 satisfies both events, so they are not mutually exclusive. Does that make sense? Okay? Because I can draw a green 7 or a green 9. They are not mutually exclusive. All right. So your numbers are in your instructions. You can look through that. I'm going to hit stop on this.